Example number 7, we are finding the derivative of the natural log of a trigonometric function. So whenever you're looking at this, the first thing, obviously there's a lot of things here that are going to stress you out. 1, the fact that it's a natural log. 2, that there's cosine x, which means trigonometry is involved. And 3, there's absolute value bars. So this is truly what nightmares are made of, except the problem is not that difficult. Keep in mind, you can only take the natural log of a positive value. So this is kind of similar to how in previous examples we see certain notations about domain where you have comma x does not equal 2. Similarly here, you're only taking the natural log of the positive values of cosine x, meaning this problem is actually capable of being solved. From here, when you do this, I have to also remember that when I'm taking the derivative of the natural log of something like u, when I take the derivative of this, it gives me u prime over u. So in this instance, and if you have the absolute value of u, then it's going to end up being the same thing, except your denominator would have the absolute value of whatever thing in the denominator. And so whenever I'm solving for this, the absolute value bars are just simply there to remind me that this is a possible problem to work. U is actually going to equal cosine x. And then u prime would equal a negative sine x. So when I'm taking the derivative of f of x to get f prime x, this is going to give me u prime, which is negative sine x, over cosine x. Okay? Once again, you can reiterate the absolute value bars if you so choose, but it's not really necessary. So f prime x equals negative tangent x, and that is your answer for this problem.